All right, I now have 2 minutes past 3 o'clock. So we're going to go ahead and get started, even though we still have a few more people that are signed in to join us later. But we'll go ahead and get started with our webinar. Welcome, and we're glad to have everyone in as we discuss our very quick hitting Arctic outbreak earlier this month on February 3rd and 4th. We've had such a warm winter that these 2 very short-lived days of cold weather was quite exceptional for just how cold it was compared to how warm it has been this whole season. So we'll talk a little bit about the science of it and how we forecast this event, some of the early signals that we detected, as well as discuss the snow squalls that occurred with this event. So we'll discuss the model data, what was some of the things that we saw as we got closer to the event. We'll talk about the messaging and the communication as we got closer to this event. And then we'll go into what exactly happened with our snow squalls and what kind of wind chill values did we observe. So let's dig into some of this model data. I'm not sure if anyone here in our audience today has ever heard of analog forecasting, but what this is, it's a technique that's used. It takes the model data in a specific run and it looks at some of the data that's occurred in events that look very similar to this event. So whether it be like the location of high and low pressure is the same, or the jet stream is the same, or the kind of moisture content is the same. You have all of these different parameters that you can see that are listed in this table to measure whether this event was similar to past events. And what you can do is you can blend that data, or you can look at that data and give yourself, say, we have 15 different analogs that we have selected. What percentage of those previous events had wind chill values below 30 degrees. And so even running into this event, this is a 96-hour forecast. So this was 4 days in advance of the event, and the GFS would run and it would look at these different model parameters and how similar in this domain it was to the forecast. And then it spits out the probability here of what the chances of exceeding wind chills colder than 30 below. So here we look at the color table, we see a lot of blues, greens, and oranges. And so once you get to this point, you're getting about to 50 to 70% chance. So even 4 days in advance of this event, model signals were already quite strong for this event being exceptionally cold. So even early on, we were able to start messaging this due to early forecast confidence. And so we did see at least a couple things, though, as we kept getting closer to the event. We saw some minor changes with regards to the surface high. And ultimately, it didn't have a significant impact on the forecast. Mainly what it did is it made the cold air focused most towards Friday evening as opposed to early Saturday morning. And so we had initially the high would have been quite strong by anyone's standards at 1,050 millibars, but over time, it trended closer in the direction of 1,040 and also began to shift a little bit further south in its location. And that would get us into some of that warm air faster. So believe it or not, the faster and the weaker trend of the surface high may have even helped us escape from experiencing even colder wind chill values. So how anomalous was this cold air outbreak to previous kinds of events? How often do we see these types of temperatures occur? Well, we can also use some of the forecasting techniques that we have with our ensembles to determine how frequent these kind of events are. And what the models were indicating were that temperatures and the height fields, or in other words, how deep this upper low was on the order of 3 to 4 standard deviations below normal. What exactly does that mean? It does mean it's very cold, but the exact numbers of this are quite impressive. If we're talking statistics on a bell curve, when you start to see 3 standard deviations, you're talking about values that are outside of 99.7% of your data if you're following a standard normal bell curve. When you get to 4 standard deviation, you are outside 90.9 or 99.9% of the data. So in other words, out of all of this data that was in this model, only a few hundredths of the percent of that data was very similar to this event. So it was an exceptionally rare event in this regard. And so we see off the chart values in terms of how these values compared to climatology in the model data, even 4 days to the event, 3 days to the event. And here's the surface pressure variability where you had the weakening high. But overall, did these sources of variability from the trend towards a slightly weaker and faster moving high, did these sources of variability really impact the forecast? Here's another forecasting technique that we often use is we sometimes divide different models into these different camps and see, okay, what does the warmer camp show? What does the colder camp show? And from that, we can get an idea of where the potential is for a forecast to bust or give us confidence in these extreme values. And you can see that between like the coldest data, clusters 1 and 4, were very cold, near 41 below to 46 below, and even the warmest was at 31 below for its wind chills. So with that, we had very high confidence, even despite some of the model variability, and despite how far off of climatology this event was, that we were in for a very cold weather day. And as we got through time, the slightly weaker high did bring up some of the values, but ultimately in the observations, I think we saw that the original data was already quite good, even 4 days out in advance of this event. And so sometimes what we also like to do is when we're talking about different thresholds, we're like, okay, what's the chance that we meet those thresholds? And even despite the model variability, pretty much most of them had the majority, in one case it was unanimous, of exceeding these wind chills that were below 40 below zero. So there was just excellent consensus all around that we were in for a very cold day amongst these different clusters. And so with that, let's quickly break off into the snow squall side of the forecast. Oftentimes with these strong Arctic fronts, they are often coincident with a strong cold front that brings snow showers with it. And with that, we did see some pockets of snow showers, and we saw the potential with good surface convergence. What do I mean by surface convergence? Just the turning of the winds in a very sharp area from mostly southwest to northwest. So this V shape here, also indicated in these isobars, showed the very sharp front. And we also saw these indications for snowfall rates anywhere between ½ inch per hour and 1 inch per hour. And there was also just fast winds along and behind the system because, again, we expected these high wind chills. So we knew that we were probably looking at snow squalls for this event. So we had the model certainty with regards to how cold this was, and we had a pretty good idea that snow squalls would be in the playbook before that extreme wind chill stuff would arrive on Friday. And so fairly early on, the coldest wind chills occurred on Friday, but we already had wind chill watches in effect Tuesday afternoon to start getting people prepared for the cold wind chills to take place on Friday. And we went ahead and upgraded to warnings even on Wednesday. And so what this did is that we started messaging the idea with the forecast sampler of different towns, and it very well highlights the distinct purples and magentas, giving this idea that you would have a very quick shot of cold air between Friday and Saturday, but surrounding that, you would quickly move back towards temperatures above zero. And so given how warm that this winter has been, we were anticipating it to be quite a shock, given how warm it was for most of the winter. So we were a little more aggressive than usual on our messaging. And so we had these types of social media posts to highlight so that people could prepare, so that emergency responders and local officials could open warming shelters and things like that, so that when action needed to be taken with regards to the warning, that could be done. And of course, we have our nice wind chill graphics. And the reason why we worry about wind chill, when there's a lack of any wind, just the radiation off of your own skin and your own body provides a thin layer of heat. But when you have driving winds, that carries that small insulating layer away. And so we always highlight the fact that when you get to wind chills at 30 or 40 below zero, it only takes about 5 minutes for frostbite to set in. So graphics like this go a long way into helping people avoid exposure of their skin when we get these conditions of extreme cold. And so with this proactive messaging, there were postponements and eventually the transition to a virtual penguin plunge, just given how cold the conditions would be over the weekend to avoid any instance of hypothermia. There were widespread school closures across the state due to the cold conditions. And as well with the snow squalls, we issued special statements that highlighted these snow squalls to alert motorists even before these high wind chill values occurred. So this is a very standard practice, but we had a lot going on and a lot that we really wanted to focus on with regard to this extreme cold and the things that took place before it. With our snow squalls as well, we like to usually post these graphics to social media that highlight the time of arrival with these kinds of tools, especially since snow squalls happen relatively fast in about 30 to 45 minutes and then they're over. Usually it's best to show these lines to kind of give an approximate timing. And we were fairly good for New York, but I think it did end up slowing down an approach to Vermont. And again, part of our messaging of this event was just how quickly this cold air arrived. It was quite a hit and run with very cold temperatures for Saturday, but by the time we got back to Sunday, Monday, and even towards the end of the very next week, we were already having warm temperatures that were competing with the level of cold that we had on Saturday. So a very rapid shot of cold air. And a lot of times when we issue the things like the seasonal weather forecasts, one of the things that we like to highlight is that it is a broad brush, that oftentimes these season-wide forecasts don't necessarily capture some of these very short-lived cold snaps that can still happen and produce these potentially dangerous conditions in a season. So very quick hitting and something that is difficult to capture a month out, but certainly was visible within a 4 to 5 day time frame. So that's a little bit in the model details and the messaging and why we proceeded the way we proceeded with our forecast. At this point, I am going to let Rodney Chai here take over and discuss the details of what exactly took place and the observations we saw from all of our different stations.
Yeah, all right. Thank you so much, Robert. And once again, thank you so much for joining us. And, feel free to ask, post any questions that you might have in the, if you look at your, the control panel for the GoToWebinar, there's the, and place that you can ask questions. You can ask in the chat or in the either in the question Q&A section. So feel free to let us know if you have any questions. So what happened? So let's talk about the snow squall part of the system. And just a reminder, what are snow squalls? They are basically very intense but limited duration period of moderate to heavy snowfall. And because of the gusty winds, you can have greatly reduced visibility, sometimes near zero visibility, and whiteout conditions. And this could create very dangerous conditions for motorists and there have been in recent history in other parts of the country, there have been like huge power-ups with fatalities from snow squalls. So we think of it like a wintertime convective thunderstorm. So in this case, you have very intense precipitation raised by in the form of snow. And here's the satellite imagery, and you would notice that we have this satellite imagery is basically visible satellite, but certain colors have been added for enhancement of certain features. So you can see the snow cover is actually in green in this case, and the orange color that you see associated with the cloud cover, those are relatively higher convective clouds. So those are associated with more, unstable air mass and, basically kind of like stormier clouds, if you would like. So you can see in this case, you have all this, what we call streamers, and basically this very cold air mass behind the Arctic cold front. And as they move over the relatively warm waters of the Great Lakes, they produce clouds and lake effect snow. And look at how well defined this streamers are, and that is testament to the cold air mass that is behind the cold front. So and then out ahead of it, those are your snow showers and snow squalls. And snow squall, like I mentioned before, it's kind of like a thunderstorm in winter. So how like in summertime we put out severe thunderstorm warning for thunderstorms that could produce large hail and damaging straight line winds. So it's kind of like a similar idea for snow squall. So in this case, we put out snow squall warning, and in fact, Robert and I, we worked that snow squall event that night. So we were the ones putting out the snow squall warnings, and when putting out snow squall warnings, we have the option of either alerting people of the snow squalls on their phones or not. But in this case, because it was happening at night, and the snow squalls did not quite reach the really intense level, so we opted to issue kind of like a generic snow squall warning that doesn't set people's phones off especially if they're sleeping at home or not really on the road. So, but it still warranted the snow squall warning. And you can see here, this is basically looking at the purple lines at what we call frontogenesis. And so frontogenesis is kind of like a fancy meteorological term that talks about how quickly, how rapidly the air is rising out ahead of the cold front. So when you have a drastic change in temperature, basically a change of air mass. So the cold front acts as a mechanism for the air out ahead of it to rise rapidly, and that's how you form clouds and storms. So it's just like in the summertime, you have a cold front, and you get a line of like showers and thunderstorms out ahead of the cold front. So the snow squalls behave very similarly. So this is what this is depicting. And and I mentioned like how drastic the air mass changes, and this is shown in what we call the steep low-level lapse rate. So lapse rates are how the temperature is changing with height. So the steeper the lapse rates, the more quickly the air mass gets colder as you go higher up. So in this case, this is ideal for gusty winds and convective snow showers. And here actually you can see, so besides the lapse rates, you can see kind of like the line of like showers and convective snow showers out ahead of the cold front along the axis of the steepest lapse rates. So one limiting factor was that as the Arctic cold front dropped to the south and east, we were also losing the daytime hours and the diurnal heating from the sun. So like in summer thunderstorms, the timing of the thunderstorms, the timing of the cold front is important as well. Doesn't mean that you cannot have severe thunderstorms in at night, but the probability decreases due to the loss of the daytime heating, which is critical for the air mass to rise in the first place. And there's something called the snow squall parameter that we use. Basically, it's kind of like a combination of the different parameters such as wind and instability. And when we see, snow squall parameters, reaching this kind of value highlighted in magenta and purple, it means that there's a higher probability of snow squalls occurring in that area. And you can see, from the observations, this is in Messina, New York, and you can see between 9:07 p.m. and 9:23 p.m. So it's just over 15 minutes. There's the period of heavy snow, and you can see it was quarter-mile visibility along with winds gusting over 35-40 miles per hour. So you can imagine if you're driving in that condition, it would not be a pleasant driving experience, to say the very least. And looking at the New York Mesonet webcam, you can see, it was kind of like the snow was falling sideways because of the strong winds. And again, the winds were gusting 36 miles per hour. And once again, this is basically showing the low-level lapse rates. And you can see why part of the reason why that snow squalls weaken as they left northern New York and then approach the Champlain Valley was because of, notice how the lapse rates are not as steep over Vermont compared to northern New York, and that, we still had like a line of snow showers, locally heavy at times, but they were not quite as intense as further upstream. And again, you can see the snow squall parameter weakened as it approach Vermont. And here's the radar loop of that line of convective snow showers, and those flashes that you see, those are actually lightning flashes. So it's just like summer thunderstorms, but in the heart of winter. And here, even though we by the time the snow squalls got to Vermont, they weakened, but it still produced a brief period of heavier snow showers. So in this case, this is the wintry scene here at the airport in Burlington. And let's talk about the extreme cold that came after the snow squalls. And comparing apples to apples, the lowest hourly observation for wind chill in Burlington was -42 degrees, and that is a combination of the actual air temperature and the wind speed. And this was a cold here in Burlington not seen since 1993, so that's almost 30 years. And this would make it the 8th coldest reading on the day itself. So you can see -42, that's number 8 on the ranking. So the last time this was reached was 1993. And the steam that was caused quite a stir on social media and broadcast media, and this was a scene looking out in Burlington towards Lake Champlain and the Adirondacks, you can see. So basically, those, because of just how cold the air mass is and the relatively warm Lake Champlain waters, that just create a lot of upward rising motion of air, similar to how you create clouds. And in this case, there is there's a term what we call wind shear, and basically rotation of air in the low levels because the wind is blowing in different directions. So that kind of creates kind of like a 3-dimensional rotation of the rising air mass. And there's nothing dangerous about this. These are kind of like similar to water spouts that they're not tornadic. So, but it does make for some photogenic pictures. And you can see these are some of the pictures that our forecasters took. So, and more pictures. So record-setting cold. So you know, not just at the surface, but also at 2,000 feet elevation above us. So 925 millibars. So you can see, like, there's a, you know, minus 30 Celsius, minus 33 Celsius air mass at 2,000 feet elevation. So it's kind of like just a little bit above the elevation of Underhill. So that's very, very cold. And how cold is that? So we have something called the sounding climatology. So basically, you know, the closest upper air site to us, where we launched the weather balloons to sample the atmosphere in real time, is Albany. And so if you look at that climatology of the weather balloons, you can see that minus 32 Celsius at 925 millibars is record-setting territory. And for comparison, the average 925 millibar temperature for this time of the year is more like minus 6 Celsius. So it's quite a bit colder air mass for this Arctic outbreak. And similarly, you compare it to gray Maine. So once again, you know, minus 30 Celsius, minus 32 Celsius, and 925 millibar is in record-setting territory as well. And so if we compare it to, you know, this year's Arctic outbreak versus last year's, so, you know, notice that in the lowest part of the atmosphere, there was no inversion. So, and then versus last year, in 2022, there was a sharp inversion that existed near the mountain summits. So, and that made quite a bit of difference, that having that inversion prevented it from being too cold versus this year. So here's to take a look at the observations. So you can see here in Burlington, see if I can, so here it is. So the black number, that's minus 13, that's the actual air temperature. Minus 27 in blue, that's the dew point temperature. And in this case, this is a very, very dry air mass. And we had that 29 in red, that's the wind gusts in miles per hour. So factoring in minus 13 Fahrenheit actual air temperature and a 29 mile per hour wind gust, it produced wind chill values in the minus 40 range. So, and there it is. It's in this case, it's actually minus 37 Fahrenheit, but you can also see that minus 103 on top of Mount Washington. And at 11 p.m., it's more or less the same, but it got colder, a little bit colder, more like minus 40 to minus 50 across the region, and minus 106 on top of Mount Washington. And here's the PNS that we put out for the wind chill value. So basically, widespread minus 40 to minus 55, and there's also the minus 80 Fahrenheit on top of Mount Whiteface in New York State. So we talked about Mount Washington, you know, how it got, the wind chill value got down to lower than minus 100 Fahrenheit. And, you know, so Mount Washington is in our, in the area of our neighboring office, Gray, Maine. And so they actually did mention in their forecast discussion that there could be something called a phenomenon that is called so the Tropopause could dip below the peak of Mount Washington. And what does that mean? So we live in the troposphere. The stratosphere is the layer of atmosphere above where we live in and above where the weather goes on. So things behave very differently in the stratosphere versus the troposphere. And in times like this, because the air mass is so cold, the tropopause, which is the dividing line between the troposphere and stratosphere, dropped below the peak of Mount Washington. And that led to some very interesting phenomenon on the top of Mount Washington, besides the eye-popping wind chill values. So we'll just take a look here and just play this video loop here. So you can see how how violent the winds were on top of Mount Washington that afternoon, alongside with -100 Fahrenheit wind chill values. So this is impressive even by Mount Washington standards. So and this is a signature of the stratospheric wind making it to the peak of Mount Washington. A very violent wind. It's not your typical day on top of Mount Washington for sure. And so and you can see how so the actual air temperature on Mount Washington was -45, but because of the wind, 90 miles per hour wind gusting to 106, that led to a wind chill value of -106, with very violent winds on top of Mount Washington. So that was a pretty memorable day for the observers on top of Mount Washington. And because even though it was a very quick hitting shot of cold, but it was enough for Lake Champlain to start freezing over. And as I'm sure most of you know who live, who have seen the lake this winter, there hasn't been too much ice cover, especially on the open water. So in this case, it was cold enough to form ice, at least for a couple of days. So we have reached the end of our presentation. So we thank you very much for your attendance. And let's take a look if we have any questions. I don't see any questions right now, but feel free to type your question into the chat box or the Q&A box. We'd love to, or any comments that you have, feel free to let us know. And we'll just give it a couple of minutes to see if anyone has any questions. Alternatively, you can also email either one of us. Our email addresses is on the screen here, or you can also access this video. We'll be uploading this recording onto our YouTube page, so feel free to, if you want to review the webinar afterwards at your own time, feel free to go to the YouTube page as well. So overall, very memorable, if not quick hitting event in an otherwise relatively mild winter. So, and we'll give it a couple of minutes to see if anyone has any questions.